trigonometry, we would be really limited with the applications that we could do if we always expected our angles to be acute angles and always had them to be what were considered the nice angles. We really want to make sure that we know how to find trig ratios for angles of any angle that you have. In this example, we'll look at what if we have a point in the plane that the terminal side of an angle, trig angle in standard position goes through. How would we find the six ratios of the six trig functions for that angle? So here we want to find the value of each of the six trig functions of an angle whose terminal side goes through the point -815. So like in an application problem, you could set up your coordinate plane, have like in your application where your points are, and then still be able to use the trig ratios by this concept. So first, let's recall that if you have a point in the plane that's any point except the origin, and it is a point that's on the terminal side of an angle theta in standard position. So remember, your trig angle in standard position comes from the positive x-axis, and if we go up and around to meet the terminal side, then that's our positive angle direction. If we were to go down and around to meet it, that would be like the negative angle direction. So when we draw these, just to start with this sort of scenario, we're going to do our up and around theta to meet that terminal side. And also remember that when we look at naming an angle in terms of what quadrant it is for a trig angle in standard position, we say the quadrant that the terminal side lands in. So this angle that's going along with this particular problem is a terminal side that's hitting, and remember the quadrants are quadrant 1, 2, 3, 4. So its terminal side is in the second quadrant. So this is a second quadrant trig angle. Now, standard position and R. So R is the distance from the origin to the point that you particularly have in your problem. Then your six trig functions of your angle, the sine of the angle is the y-coordinate of the point over r. The cosine of the angle is the x-coordinate of your point over r. Tangent of the angle is y over x. Cosecant of the angle is r over y. Secant of the angle is r over x. And the cotangent of the angle is x over y. So also r is the square root of x squared plus y squared. Now when I look at this problem, I can actually look at turning this into a right triangle where I drop the vertical down to the x-axis and then show that being my right angle. If you're going to do that, making your right triangle to help you remember it from your trig ratios within the right of angles in a right triangle, remember you always draw from the point to the x-axis. You never go to the y-axis. It won't give you the right values. You always have to draw from the point to the x-axis. No matter what quadrant it lands in, you need to go from the point to the x-axis. Okay, so that's our triangle. And if I wanted to just kind of look at it as well as why they set this up, my x-coordinate is the distance from the origin horizontally until you get underneath the point. So that's your -8. Your y-coordinate then is your vertical to get to the point, so that's a +15. And our hypotenuse is the distance from the origin to that point. So your r, that distance between the origin and the point, is really the hypotenuse of that right triangle. That's why r is the square root of x squared plus y squared. So for our example, x is equal to -8, y is equal to 15, and r is equal to the square root of -8 squared plus 15 squared. Now remember, -8 quantity squared is 64, so -8 times -8 is a +64. 15 squared is 225, And you have to add those together before you do the square root. So r is equal to the square root of 289. And the square root of 289 is 17. Now in this one, that does simplify completely to a rational number. Sometimes you're going to have an irrational number for r. And so you want to simplify your radical as much as you can. But it's possible that you might have a radical in your ratios of your trig ratios of that angle. So just following these definitions, I would have the sine of theta is y over r. So remember, this is your x coordinate and your y coordinate. So y is 15 and r is 17. The cosine of your angle is x over r. X is equal to negative 8 and r is 17. The tangent of the angle is y over x. So y is 15. X is equal to negative 8. If I could simplify any of these, I would. My tangent of my angle is 15 over negative 8, or I could think of that as negative 15/8. The cosecant of the angle is r is 17 over y is 15. The secant of the angle r is equal to 17. X is equal to negative 8. And then the cotangent of the angle, x is negative 8 and y is 15. So when I'm writing these out, it's very important that when you write what the value of each of the 6 trigonometric functions of this angle are, you write like the sine of theta is equal to 15/17. You have to have the trig function acting on an angle, and then your equal sign, and then the ratio that it's equal to for that. Now let's look at this the other way to just verify that if I follow this specifically, I get that, and it makes sense that that's the definition. So if I look at our picture and we drop our vertical down, our theta going across to that terminal side, this is our reference angle of theta going to the nearest x-axis with that. And since that's my reference angle, that's the angle that if I take the trig functions of that reference angle, I'll get the same trig ratios of using our applications with theta, or definitions with theta. So I can write that the sine of theta is equal to, thinking that as your reference angle, sine from right triangle trig is opposite over hypotenuse. So with this angle being our angle we're focusing on, negative 8 is our adjacent side, 15 is our opposite side, and our hypotenuse is the 17 that we could have also gotten from the Pythagorean theorem. We would have done this exact same work for the hypotenuse with the Pythagorean theorem, because that's where this comes from. So our sine theta is opposite over hypotenuse, so 15/17. Our cosine of the angle is adjacent over hypotenuse, negative 8/17. The tangent of the angle is opposite over adjacent, so negative 15/8. The cosecant of the angle, well, cosecant is the reciprocal of sine, so the cosecant is going to be hypotenuse over opposite, so 17/15. The secant of the angle is the reciprocal of cosine, so that's going to be hypotenuse over adjacent. And then the cotangent of the angle is the reciprocal of tangent, so that's going to be our adjacent over the opposite. So when you look and compare between this definition of how to find the trig function of a terminal of an angle whose terminal side goes through a point, and what we had here, as well as doing our right triangle with the reference angle and finding the trig ratios of each, you see that we're going to get exactly the same thing because we are just looking at the same concept from a different perspective. And hopefully you've found this to be a helpful video in finding those trig ratios of an angle where you have a point that the terminal side goes through. And just again as a reminder, when you have these sorts of problems, you always bring your from the point to the nearest x-axis to form that triangle if you're going to work it with doing the reference angles and going from there to get your trig ratios.